Mr. Price here, lesson 6.4, proportional and not proportional. Let me give you the basic idea of proportional. 1 out of 2 is the same thing as 2 out of 4. It's proportional. 1 out of 2 people is just the same rate, the same ratio as 2 out of 4. Now I'm going to explain this a little differently than the book, although most of the book will take just a couple minutes here to talk about. 1/2 we know is 2/4, or 3/6, or 4/8, or it's all in the same what? Ratio, proportion. Here's another way I want you to get used to. Turns out that 1 times 4, same thing as 2 times 2. We call that the cross product, when you cross multiply. Proportional means the same thing. Same thing. If I was going to give 1 out of 3, 1 out of 3 is the same thing as 2 out of 6, but it's not the same thing as 3 out of 10. Why? Because 3 out of 10 is not reducible. You can't reduce it down to 1/3. One way to look at it is just 1/3. Let's see, 2 6, 1/3. Another way to look at it, this is twice as big. This is twice as big. This is proportional. This is not proportional. Let's go back and get rid of that 2/3 or 2 6. We want it as simple as possible. 1 times 3 is 3, but 3 times 3 isn't 10. This is not proportional. By the way, 3 is not 1/3 of 10. It's not quite. So proportions you've had since ratios and fractions, from reducing, or I call it upducing, making equivalent fractions. So that's not that complicated. Some things are proportional. They go up the same amount. Page 282 has a great example. Great example with circles. Here's an interesting topic. It says y equals kx. This k, and I've seen this in Algebra 1, Algebra 2, it's called the constant of proportionality. Sometimes there's an extra number. Sometimes there's an extra number going on with that. The example they give is pi. When you're taking the area of a circle, when you're taking the circumference of a circle, I don't know if you know this, but you take any circle. You take a circle and you measure around, we call that circumference, and you divide it by the diameter, you always get one number. That's pi. Circumference divided by diameter is always, if you do it right, about 3.14. That's where the formula comes from. The formula for circumference is pi times diameter. This is a ratio, this is like a proportion of a formula. Every time you want to find the circumference, you take 3.14 times the diameter. It's proportional, all right? I think I have a better ratio, better example. I use this one a lot. How much money would you have in your pocket if you had nickels? How much money would you have in your pocket if you had nickels? First question people usually say is, I don't know. Well, I'm not going to edit that out. Sorry about that. It depends, right? What happens if you have 1 nickel? 5 cents. I'll make a little chart here. 2 nickels, 10 cents. 3 nickels, 15 cents. 4 nickels, 20. It's proportional. 1 out of 5, 1/5, 1/5, 1/5. It's all that. We can graph that. We can graph that. 1 nickel is going to give you not 1 penny, but 5 cents. 1 penny, 1 nickel, 5 cents. 2 nickels, 10 cents. 3 nickels, we can graph that, by the way. Yeah, you can graph that. What happens if you have 0 nickels? 0 nickels, no money. 1 nickel, 5 cents. 2 nickels, 10 cents. 3 nickels, 15 cents, 20. It is proportional. Sorry about the graph, it's terrible, but that's okay. Here's the key, especially for you doing Algebra 1. If it goes through the origin, if it's 0, 0, it is proportional. Because when you take 0 times 5, you get nothing, 0. There are some places where you would add on something back here. This is proportion. This number here is the constant of proportionality. On a circle, that constant of proportionality is pi. On money, in case of nickels, the ratio or the constant of proportionality is 5 cents for each one. Sometimes there's a figure that you multiply by, a constant. This was always constant because there was money, 5 cents. In a circle, it was always 3.14 because that's pi. The homework shouldn't be too bad.